So here we have to calculate our 9 derivatives, right? That first step we can say del L over del W 2 1 1, del L over del W 2 1, and then del L over del B 2 1. This is the first three. Then second, del L over del W 1 1 1, comma del L over del W 1 2 1, comma del L over del B 1 1. This is the second step we have to find out, and the third one is del L over del W 1 2, del L over del W 2 2, and then del L over del B 1 2. As you're seeing the diagram, we have team and grace, weights and biases. Y hat is equal to loss. Then here we need to find all the 9 parameters with respect to loss function derivatives. Alright, so we'll start with the first set, that is look these derivatives. Will find out. It's not difficult task, right, as it is a mathematics, right? But I want to give you intuition that you guys need to understand that we have to minimize our loss function, and L depends on y hat and y hat depends upon the W211. Then why we are finding derivatives of this, what we are getting from this quantity, that we need to understand, right? Look what is happening, you have to understand. As you're seeing the figure also, that we have y-axis, x-axis, and there's a one slope. Then it is look like some kind of hyperbola kind, that from the first principle we have to find the derivatives, that is dy over dx. That also we call slope, as we have already learned in mathematics. Whenever we are finding out dy over dx, so what does that means? It's a slope. You can see graphically, y is one quantity and x is another quantity, and we need to find what a little change occur in x, then what changes arises in y, right? As you see graphically that plot, this is a slope. These things you have learned in mathematics, right? Now here del L over del W 211, if I'm doing little changes in W 211, just listen carefully here, that what does del L over del W 211 means. If we are doing little changes in W211, then what changes arises in L, right? That thing I guess you have understood. But if you understand this change, that you will see W211 is not directly related to loss, means its direct change will not reflect here. Means if we do some changes in W211, then our y hat will change, and when y hat will change, then some changes also reflect on the loss, right? You can't directly find out del L until you will find del L over del y hat. So that is multiplied by the del W211, and then multiply del y hat over del W211. So our formula is here that del L over next. Now if we look at the formula, that del L over del W211 is equal to del L over del y hat multiplied by del y hat over del W211. This is said to be chain rule of differentiation. Alright, del L over del y hat is equal to del over del y hat multiplied by y minus y hat. So the resultant is minus 2y minus y hat. Alright, this is we are getting after differentiating it. Del y hat over del W211 is equal to del over del W211. So inside the square bracket O11 multiplied by W211 plus O12 multiplied by W221 plus B21. So if we differentiating W211, right, with respect to W211, this figure inside the square, then you can see where is 11 in the base, and we can see in only one item here, and the next one there is O12 and W21 will become 0, B21 become 0. Alright, this is the differentiation rule as you see in the figure. This differentiation is very easy as del W211 is only having one term, that is O11 and W211. Other term will be 0 as the resultant. So what we are getting here, del over del W211 inside the square bracket O11 W211. So the resultant will be O11. That W211 will cancel and gives 1 after differentiating. So O11 is the resultant. Now, going by this logic, we can write del L over del W211 is equal to minus 2y minus y hat multiplied by O11, and this is our first equation. Right, first thing we have already calculated. If you'll understand here, then it is very simple. L depends upon y hat and y hat depends upon 5 things. W2 to 1. Then again write chain rule and find del L over del W2 to 1 is equal to del L over del y hat multiplied by del y hat over del W2 to 1. So if you notice that del L over del y hat, that is common on both the equation, and we have the del L over del y hat value, so we need to find out the only del y hat over del W2 to 1. Okay, now del W y hat over del Y2 to 1 is equal to del W2 to 1 multiplied by the inside the square bracket O11 multiplied by W211 plus O12 multiplied by W221 plus B21, that is our bias. So what is the resultant? That is O12 resultant, as W21 is in the base of that differentiation. So what we are getting, the equation second, del L over del W21 2 to 1 is equal to minus 2 multiplied by y minus y hat and O12, right? Now we are finding second equation also. Now we have to find for bias, same rule will apply for bias loss, depends on y hat and y hat depends on b. I guess you are noticing the pattern now. Del L over del B21 is equal to 2L del L over del y hat multiplied by del y hat over del B21. So del y hat over del B21 is equal to 1. By going this logic, we find del L over del B21 is equal to minus 2 times y minus y hat. This is our bias and third equation. So if we find the first set, if you see, alright, right, yeah, it has written formula above. Del y hat over del O11 is equal to del over del O11 inside the square bracket like before, W211 multiplied by O11 plus W221 multiplied by O21 plus B21. So we are differentiating it, the rest will be the 0 where O11 is not present, so only in the first term O11 present with the W211. So the resultant will be W211 as you see. Similarly, del y over del O12 will do the same thing. Alright, and what we are getting, W221. Now next, del O11 over del W111. That is team time W111 plus grade time, grade multiplied by W121 plus bias, we have here B11. When differentiated, then other value will be 0. Alright. So what we are getting less, as you're seeing in the figure, that xi1 we are giving it for not confusing it, not making it difficult. We are giving this ith term, that I is equal to rho in the theme in the grade, then O11. Similarly, when we find next terms, that del O11 over del W1 to 1 is equal to xi2, that del O11 over del B11 is equal to 1. Alright, then del O12 over del W112 is equal to del over del W112. Inside the square bracket, team W112 plus grade W122 plus B12. Alright, now after differentiating, what we are getting, where del W112 terms present, that will be differentiate and other rest will be 0. So that is equal to theme of xi1, that del O12 over del W112 is equal to theme of xi1. Alright, and now next one, del O12 over del B12 is equal to 1. Right, yeah, it has written formula above. Del y hat over del O11 is equal to del over del O11. Inside the square bracket, like before, W2 11 multiplied by O11 plus W2 21 multiplied by O21 plus B21. So we are differentiating it, the rest will be the 0 where O11 is not present. So only in the first term O11 present with the W211. So the resultant will be W211, as you see. Similarly, del y over del O12 will do the same thing. Alright, and what we are getting, W221. Now next, del O11 over del W111. That is theme time W111 plus grade time, grade multiplied by W121 plus bias, we are here B11. When differentiated, then other value will be 0. Alright, so what we are getting less, as you're seeing in the figure, that xi1 we are giving it for not confusing it, not making it difficult. We are giving this ith term, that I is equal to rho in the theme in the grade, then O11. Similarly, when we find next terms, that del O11 over del W1 to 1 is equal to xi2, that del O11 over del B11 is equal to 1. Alright, then del O12 over del W112 is equal to del over del W112. Inside the square bracket, team W112 plus grade W122 plus B12. Alright, now after differentiating, what we are getting, where del W112 terms present, that will be differentiate and other rest will be 0. So that is equal to theme of xi1, that del O12 over del W112 is equal to theme of xi1. Alright, and now next one, del O12 over del B12 is equal to 1. Now you can see all the derivatives in the figure. What we are getting, del O11 over del W111 is equal to minus 2 times of y minus y hat multiplied by W211 xi1. This is the first term. Here in the step 2, del O11 over del W121 is equal to minus 2 times of y minus y hat multiplied by W211 multiplied by xi2. Then the third term is del O11 over del B11 is equal to minus 2 times of y minus y hat multiplied by W211 These are the second three terms we are getting, and the third three terms. These all remains three answers. Alright, similarly we have to do, remember this, del y hat over del O12 is equal to W221. So other values will be del O12 over del W112 is equal to minus 2 times of y minus y hat W221 multiplied by I1. Second term is del O12 over del W122 is equal to minus 2 times of y minus y hat W221 multiplied by xi2. Then third term will be del O12 over del B12 is equal to minus 2 times of y minus y hat multiplied by W221. So finally we find out all the 9 trainable parameters here. I solved this because I want to you my folk to understand the pattern. These all our 9 derivatives. If you analyze all those formulas, then you can easily apply it on the algorithm, right? Now we will use the values and find out the solution of our query. Alright, now we learn to calculate derivatives. It's time to apply it on our data set for back propagation, and we have 9 trainable parameters. So let's summarize the things a little bit. Initially what we have to do, so step we will give value to all weights and biases, 0 weights and biases in it. Initialize all this randomly. Weight is equal to 1 and bias is equal to 0. It is a simple way to initialize. Alright, in step 1 we run a loop. So how many times we repeat the process, it depends upon how many number of data in our data set. Means we are iterating the process, right? And like from epochs we are giving the values. So in the next step, one student will do forward propagation, then prediction, then they get packaged, then we do prediction and salary predictions, right? Then we will calculate the loss function by using MSE, then adjust all weights and biases, and on the basis of loss we will adjust our base and bias, right? It all depends upon target value, then how many number of iteration we have to do so that we will achieve our target value. And what is the formula to adjust this gradient? Weight gradient is that is W nu is equal to W old minus eta del L over W del W old. Iterate this process until we reach target. What happening? We will adjust weights and biases in every situation so that it will slowly reach the target value. That loop may be 10 times, 20 times, or maybe 100 times sometimes. Y minus y hat, this iterative method of updation of values in each epoch said to be back propagation. Okay, so I hope everything is clear.